Okay, today we're going to start by going over the graphs of these logarithmic functions. And to sketch the graph, we're going to use the facts that we know that logs are inverses of exponential functions. Okay, got to understand that fact, and we're going to use that to our advantage. Something we worked on in chapter 1 is that inverse functions always are reflections of each other in the line y equals x. So that'll help aid us in the graph. Okay, so once you write this down here, if we're going to start with y equals 2 to the x, okay, I just took the f of x, replaced it with y. What do we know about inverses? To find an inverse function, we interchange x and y. So the inverse becomes x equals 2 to the y. Okay. Now how do I solve that for y? Or express it in terms of y? I convert it to a log, like you worked on day 1. So I say log base 2 of x equals y. Okay. And this isn't a process you have to do every time. I'm just making sure you have an understanding of why they're saying log base 2 of x is the inverse of 2 to the x. They are. Okay. Interchange x and y, and then you convert it, and that's what we get. Okay. All right, so we did 2 to the x in 3.1. This is a pretty easy problem for most of you. How do I figure out these values? I take -2, I throw it in there. It's 2 to the -2nd, which is 1 over 2 squared, or 1/4. This table's filled in for us, but you guys did this last section. Okay. All right, so now that we know that these are inverses of each other, to get the table of values, you don't have to get too complicated here. I take the domain and range and I flip-flop it. These x's become these y's, and these y's become these x's. Okay, so reverse that order pair. And then you continue that. Okay, if -1 and half is on the graph, then half -1 must be on the inverse function. Okay. All right, so let's go plot these coordinates for log base 2 of x, and let's see what the result is. Okay. So 1/4 -2, right here. The other one was 1/2 -1. 1, 0, 2, 1, and 4, 2. Okay, I'm going to add something to this graph. So before you draw it, pay attention to this. Remember the exponential function, as long as it wasn't shifted around, had a horizontal asymptote at y equals 0. All right, so we got a HA at y equals 0. Remember, inverse functions, we interchange a lot of things with the domain and range. So the asymptote is also flipped. There's going to be a VA for this log right here at x equals 0. Let's label it. So there's a VA at x equals 0. That's going to serve as kind of a border for our graph now. Just like for the exponential functions, we weren't supposed to make that pass over the y equals 0 line. Well, now I got to make sure this log graph doesn't pass over this line. Okay, so the graph will look like this. I'm just going to kind of draw a vertical line right along it, along the y-axis, and then like that. Okay. All right, now remember inverse functions. That's why this is not an asymptote. It's a symmetry line, right? Just to help you confirm that they should look like mirror images of each other over that line. So if you want to add that, this is not an asymptote. This is just a symmetry line at y equals x. Okay, let's turn the page. Now, there's 2 more here. I'd like to just quickly show you the next one. You don't have to write it down and have you try the next one on your own. Not much is going to change here with a base of 3. Okay, sure, the values are different, but then we interchanged x and y, and look, once again, we see that they're symmetric. We see an asymptote at x equals 0, slightly different shape. Okay, all right, let me push you in the right direction on 22 and let you try this one on your own. Okay, so now we have a base of e to the x, which is that 2.7 number. Okay, and these values aren't filled in for you. So you've got an option. You can go to your clear screen and do this individually and do e to the, what's the first one? Negative second. E to the negative second. Okay, or since we're doing multiple values, why not use the table again? That might be wise to do. So if I go to y equals and throw in e to the x, I can get through that a little bit more efficiently and go to my table and grab the values. Okay, so you go do that, then flip it around for the natural log, because these are going to be inverse of each other, and get both graphs down. Okay, go ahead and pause and give it a try. All right, here's your feedback on 22. Remember, if negative 2.14 is on a function, its inverse must contain 0.14 negative 2. And then here's the results. Make sure the asymptotes help guide your graph and bend it the right direction. Okay. All right. So in summary, we should always realize that with these log functions, this vertical asymptote kind of serves as a fence. It doesn't go to the negative x values. It only includes 0 to infinity. Okay. It always includes a VA of x equals 0. I want to add that to that box if it's not already in there. Okay, pause if you need more time on that. I'm going to move on to the next page. All right, so for 23, 24, and 25, we're mainly going to focus on finding the domain and finding the vertical asymptotes. Okay, finding the x-intercepts and the log functions and sketching these graphs. Sometimes those online graphing calculators can be tough to use, so I'm trying to show some tolerance for that and not expect you to be able to do all of this. But we can find the domain and vertical asymptotes by hand. Okay, and then we'll throw in the calculator to check our answer on these, and then if you can, this will just kind of be extra stuff that could help you. Okay, all right, so let's start with domain. As I mentioned before, and I'll kind of rewrite it up here. If you want to write this down, go ahead. So here's kind of our base form of log, a generic definition of log we dealt with on the first page. Y equals log base b of x. To find the domain, here's our process. We're always going to take what's ever right here. I've also referred to this as the argument of the logarithm. So you're going to take the argument and you're going to set that expression greater than 0 and then solve it. 23 just has x, so that's going to be pretty easy, but you can see the other two have different things going on in the argument. Okay, we'll get there. All right, so the domain for this one. Simply put, right, just x is greater than 0. Now, if this is in the back of the book or multiple choice, it may be in interval notation. So we'd say 0 to infinity. All right. Okay, now remember, all these log functions have a VA at x equals 0 unless it's shifted around. There is no horizontal shift going on. You'll see it on the next two. But for now, it's going to remain at x equals 0. Okay. All right, that'll usually be enough to identify a graph from 4 choices on a multiple choice. Okay, but I'm going to continue on. If you have a graphing calculator, I'd like you to follow along and do this. All right, so right now we've got the VA, right? Here's my wall at x equals 0. I know my graph is going 0 to infinity, so it should be this way somehow. But let's just try to go get the x-intercept from the graphing calculator and then maybe the table values or trace to help me sketch the graph and finish it. Okay, so using the graphing calculator. So graphing calculator skills. The x-intercept is going to be, All right, so let me show you how you can punch this in. If you got an older graphing calculator, you might not have this option. It's another reason why I'm kind of making this extra. All right, if you have one of my yellow calculators in here, though, you should be all set. So go to your y equals, and I want you to hit the math button. It's the left-hand side near the top. And then there is a log base button. I've actually hit up arrow, gets me a little quicker. But you can either go down or go up, and I'm looking for that one right there. If you don't have it, then you don't have this option to do this. Okay. The only option you would have is base 10 and base E, right? Because I do have buttons for that. So if the problem called for that, like 25, you do have the right to the log button. Okay, so I'm going to hit enter, and it's going to allow me now to punch in whatever base I want. So I can punch in 3 there, and I can plug in the x, which is in the argument, and then the +2 is outside of the argument. So right arrow, +2. Okay, now I can hit zoom 6 or graph, and I get my graph. Okay, so things are matching up, right? We expected a domain of 0 to infinity. That's matching up. There's a VA or wall on this thing right there. Now let's just kind of trace to get the x-intercept. It might be hard to see. I might have to zoom in a little bit. I'm going to hit zoom 2 to get a better picture of this x-intercept. It's right here. And so I'm just going to hit the trace button again to move around. Looks like my x-intercept is approximately 0.1. Okay, so it's 0.1 and a y value of 0. So I'm going to plot that point at 0.11, 0. All right, and I know where the asymptote is at. And I'm just going to grab another couple points on that bend and call it good. So I'm just going to trace a little bit further this way. Looks like at x equals 0.5, I'm around 1.4. So 0.5, 1.4, and maybe I'll go a little bit further. What's this spot at y equals 2? 1, 2 is another point. Okay, so that just helps me create this bend a little bit, and then it looks like it bends quite a bit once it gets through there. Okay, so there's the log graph using the graphing calculator. Okay, let me take you through 24 as well, and then let you try 25. Okay, 24, let's start with domain again. Now I'd have something more than just x. So whatever this is, we say, all right, I'm going to set that greater than 0 and solve it. Add 3 to both sides, and it's solved. So that becomes the domain. So my domain is x is greater than 3, or we'd say parentheses 3 to infinity. Okay, these are shifted around. Just like in section 3.1, we saw some shifts with exponential functions. Okay, if it's outside the function, like 25, that's a vertical shift. If it's inside the function, it's horizontal. So this -3 is going to be a horizontal shift. I'll put that in parentheses. We got a horizontal shift. 3, when we subtract, it goes to the right. 3 to the right. So that also moves our VA. All of our VAs have been at x equals 0 up to this point. Now it's going to be picked up, moved over 3 units, and set down. So now I have this VA at x equals 3. Okay, based on this shift. So VA at x equals 3. Okay. From there, I'm going to punch this in the graphing calculator and get the graph ready. I'm going to pause so I don't run out of time. That's what I'm doing next. Okay, so here's the result of punching this in. Now it's actually upside down. That's what the negative did too. It reflected it. That's okay. We can see the VA. We can see the 3 to infinity. I traced an x-intercept at 4, 0, and then maybe just get a couple more coordinates to plots, and then you're good. Okay. All right, pause it now and try 25. Once again, focus on the domain, focus on getting the vertical asymptote. Anything after that is just kind of extra, okay? So here's the graph to 24. Here's the answers to 25. Domain, -1 to infinity. VA at x equals -1. And then we can pull some things from this graph to finish it. Maybe like your y-intercept, x-intercept, and draw your graph. Okay, and that's it for this section.